Good morning, good afternoon, or good evening, wherever you are this evening. Thanks for joining us. My name is Maria Colgan. I'm one of the product managers for the Oracle database. And in this session, joining me today is Andy Rivenes, who is our database in-memory expert. And that's who I'm going to turn it over to now so he can take us through the session.
Thanks, Maria. Hello, everybody. So we're going to talk about automatic in-memory today. I just want to make sure I point out that in our office hours page, if you scroll down, you can see our past sessions that we've held. And we actually held quite a few of them. And then there's also some resources. I'll probably mention the blog or the resources page, and that's on our database in-memory blog. Plus we have some other links there if you're interested in In-Memory Advisor, if you want to try to figure out whether database in-memory might work in your environment. And of course, we've actually covered a lot of these things in our previous sessions, but today we're going to talk about automatic in-memory. And so we'll go ahead and dispense with that. I'll start off with a few slides. See if I can go full screen, just to make it easier to see. And then I have a couple demonstrations. So I'm going to talk about some background and how automatic in-memory kind of works, show you a little bit of it, and then we'll talk about some of the details about it, so hopefully you can understand what to expect, and then we'll demo some of that as well, and hopefully we'll cross our fingers that all that goes well, and we'll be on our way. So again, my name's Andy Rivenes. I'm a product manager for database in-memory. I work out of the Oracle Database Development Group with the Database in-memory group. My Twitter handle and email address, and then we have, of course, Maria Colgan, and that's her Twitter handle if you want to follow her. And with that, I do have one bit of business to do. We are going to have what we call a Database in-Memory Summit in June. So these slides we're recording the session, we'll get that posted after this session. And so you can go back and look at this if you want. But you don't have to, other than, I guess you have to sign up because it's part of the Ask Tom setup. But other than that, you can just plan on joining the In-Memory Summit if you'd like to learn more about database in-memory. So the registration URL is there. I don't know, Maria, I don't know if you can cut and, I didn't think to.
I can add it into the chat so that folks can see it.
Have to, yeah. Can you cut and paste? I don't know if you have to type it in. I'm sorry about that. I didn't think about
all right.
Making that available. I'll give that a second, because actually here. Is that easy enough to type in, do you think? Or?
Yeah, I got you.
Okay. All right. So I just wanted to make folks aware of that. I'll show it again at the end just in case. But we're going to have a bunch of folks talk, including customers. And if you want to hear about database in-memory from development, our development managers, and some of the new things that are coming, plus some of the stories and best practices around database in-memory, might be a good opportunity to find out more. And with that, let's get back to our topic at hand, which is automatic in-memory. So we actually introduced automatic in-memory back in 18C. The idea behind it is to let the database manage the contents of the column store. And so to do this, we leverage something called heat map, or access tracking statistics. And if we go back in time even further, in 12.1, we introduced something called automatic data optimization that worked at the segment level on disk in the row store. And that was part of advanced compression. And then in 12.2, we introduced automatic data optimization for database in-memory, and that also leveraged heat map. And so I'll give you the background, and we did an Ask Tom session on ADO, and actually we did it on this version of AIM. So this is really just a review, and I will have a couple of links in the slide so you can get to it. But basically on our Ask Tom office hours page, you could go click on the links for our sessions that we did on ADO and AIM if you wanted to get more information. However, I'll get back to what I was wanting to talk about, which is AIM. And so we don't actually use heat map, but we use the underlying framework that heat map is based on to classify objects in the column store or in the database actually that are enabled for in-memory. And the idea is to populate the most active objects and then evict the least active objects, since we kind of know that the column store is fixed in size. So you only have so much memory. So we've always said that the column store and database in-memory is not a cache, it's a store. This takes us a little out of that in the sense that essentially what winds up happening is at the segment level, not at the individual block level like in the buffer cache, but at the segment level, it does in effect become a cache in the sense that we're trying to keep the hottest data or the most active data in the column store to give you the biggest bang for the buck. And that's kind of really the motivation behind automatic in-memory. Plus, we have the in-memory advisor. We've talked about how do you decide what objects to populate in the column store, and what better way to figure that out than let the database figure it out for you based on what objects are actually being accessed by your applications. So that's kind of the gist of it. There is an in-memory automatic level parameter that controls this. So in 18C, oops, the right page here. I had a couple, so let me review. I'll go back, I'll get to that in a second, sorry. All the features, you have to have the database in-memory enabled in order to use automatic in-memory. That kind of makes sense. You don't have to enable heat map, but you could. Heat map, actually, since with in-memory, if you have database in-memory, you can use heat map. And heat map can be of value even outside of AIM or ADO if you're trying to figure out what objects are popular, what objects are getting full table scanned. And so heat map is available, but database in-memory and automatic in-memory, well, automatic in-memory doesn't require that you enable heat map. So we're not going to use heat map. We're just going to worry about the in-memory automatic level parameter, which I'll talk about in the next slide, sorry. And for anybody asks, just like with database in-memory compression, automatic in-memory and heat map does not require advanced compression. So it's all inclusive with database in-memory. So you don't have to have any other options enabled to make use of database in-memory or its features, which AIM is one of them. So I'm sure somebody's going to ask that, right? All of this is controlled with an initialization parameter called in-memory automatic level. That's where I was headed before I got that slide there. So I probably should have changed the order. Anyways, by default, it's off. So you have to enable automatic in-memory. Like a lot of things with Oracle Database, you actually have to take action to enable it. Initially in 18C, we had only the low and medium levels. And so the idea was that you could choose the level of activity that you wanted automatic in-memory to manage. So I have some descriptions here, but I'm going to go to the next slides because I actually, in a more verbose manner, talk about how these two options work, and then we'll move on because this is really just review from 18C. And I did it again. So it's enabled for in-memory only, in-memory. So the way to bypass this, and we'll talk about this a little bit more with the AIM and 21C, which is what I really want to talk about. But if you set the priority to none, then AIM will manage it. So this is, and even in the high mode that we'll talk about, this is a way to avoid having AIM act on your object. So, but by default, priority set to none means it's eligible for AIM operations. If you have an ADO policy, which is one of the reasons I mentioned ADO, the automatic data optimization, which is a policy-based feature, again, we introduced in 12.2, that can allow you to manage both the compression level and storage tiering of objects, both earlier at the segment level, but also in the column store, the ability to manage where the objects go based on, say, time. Usually people use this for partitioning when they want a rolling window in their warehouse and they want to keep just the most current partitions in the column store and then roll them out on some time-based, like maybe every 30 days or 60 days. And so you can set up a policy to manage that automatically. So that's ADO. But if you have an ADO policy that prevents eviction, then AIM will leave it alone. So that's kind of the takeaway there. So with low in-memory, with in-memory automatic level set to low, when you populate an object, if it's based on this idea of access patterns, will basically can evict cold objects, or at least the least active objects, in order to make room for the object that you're actually accessing that if it's been accessed enough. So it's a very the least intrusive way to manage eviction versus population. Now I should mention that this only takes effect when the column store is under memory pressure. And I'm going to talk a little bit about that. But basically when it's full, as long as there's enough space in the column store, AIM actually doesn't get involved. And so you can, and it's only when you have more objects that eligible to be populated, then you have room where they will fit in the column store. Hopefully that makes sense. And so, so low is triggered, and this is a little bit more detailed than what's in the documentation, which I'm going to go have the documentation updated so that it's a little more clear, because it's not as clear in the documentation. I was looking at it and I actually talked to development a little bit about this and said, well, this isn't really the way it fully works. And so I want to make sure people understand how it does work. So anyway, so at the very low level, basically it's triggered by access of an object. As it gets hot enough or hotter than other segments that are in the column store, it can result in evictions of those colder segments. And so that's kind of, it will make room for population to occur. So that's the gist of low. Did I just confuse everybody, you think, Maria, or is that, I'm trying here. So
no,
some of this is hard to explain.
I think that was reasonably clear when it's going to kick in. I think it's going to get a little more tricky now to keep in mind when we get onto medium.
It is. So medium now becomes quite a bit more complicated because it's now it's automated in this. And so what I did is it gets triggered when either the column store is under memory pressure. Remember, our definition is basically when you've got enough objects populated that you can't fit any more into the column store. So that you're at memory pressure in the sense that there isn't enough room to populate. So that's when AIM kicks in. Otherwise, AIM is never in the picture. And then we have this idea of this IMCO in-memory. It's a background process that manages the column store for repopulation when data changes. And we've tacked on the AIM processing into that cycle. So it kicks off a task, and we'll talk about tasks as well. And then the other way this works is that if an in-memory object is enabled, and it's not currently populated, but it gets accessed, and it's had enough accesses that it's more accessed than other objects. In other words, it's hotter than some of the cold objects. And so in either of these cases, it's going to kick in and take a look at, and this is kind of the key, the access statistics of the objects that are in the column store and that are enabled for in-memory. And I'm going to show you this, so you don't have to remember all this, but we'll have this documented and we'll get it in the documentation so you can go through and read it. And if you have questions, you can obviously ask us, but hold off just for a little bit, and I'll try to hopefully make this a little more clear actually by showing it to you. So this is how this works at the medium level. And this, the way this works is basically how the high level in 21C is going to work as well. So it kind of folds in together. In addition, and I'll show you some slides about this, there is a window. So the idea is that we're not going to go back forever looking at what has been accessed. We have some defaults, but we allow you to set up the window that the access statistics are viewed in so that you could have this match, say, your business access. So if you're doing heavy month-end processing, that's going to skew the contents of the column store from your normal processing. And so you can control how we look at that data so that you don't wind up with objects that were really heavily accessed at one point in time, but now aren't being accessed and are still being kept in the column store because their access statistics say, well, they're the most busy objects. So we'll talk a little bit about that as well. So that's what that kind of talks about with the AIM windows and the access statistics and this idea of how you track all of that. And I should say that this topic does generate a lot of discussion within development because everybody thinks of this in certain ways. So again, that was my purpose of doing the review and kind of documenting how it's supposed to work, and then we can talk about how it works with High, and then I'll show you some demos. So, but we did talk about automatic in-memory, the 18C version that I just showed you the 2 parameters for, and ADO in the framework of ADO back in 2019. So you can go back and look at those sessions if you're confused completely or just curious and maybe want to take a look at trying to make use of those. All right, so now we're on the new 21C feature of automatic in-memory, which is, I think, very cool. This is on our journey, as I like to say, to making the column store fully automated. In other words, all the objects populate and are kept populated based on their usage, and you don't have to do anything. All you have to do is set up the column store and run your applications, and no more needing to run the in-memory advisor, no more needing to alter tables to be in memory. You just run. And that's kind of, I think, a really exciting prospect with database and memory, because that's what folks will ask a lot, because let's face it, not everybody has enough memory to put their entire database or application active tables into the column store. Where, memory just isn't that plentiful yet. And maybe it never will be, I don't know. But anyways, so we have a new parameter called High. So we've got low and medium from 18C, and now in 21C, we have in-memory automatic level High. So you can set High, it's not on by default. And what that does is that literally goes through and marks all of your application tables to be eligible for in-memory. It does it automatically, and I'll show you that in our demos. And then based on access statistics, it will manage not only population, but it will gives the ability to compress columns and to evict, and so it'll do all of that. The framework of AIM is based on not only the memory pressure issue that I talked about, but also on a working data set size, or a working data set. So the idea obviously is to have the most active or the biggest bang for the buck, the objects that will give you the biggest bang for the buck in the column store. And we understand that that can be a moving target. And so based on your business requirements and your workload, that could be different at different times of the day, at different periods of times in the month or the week. And so the idea here is that based on access and your business requirements, we'll try to make sure that the most active segments are in the column store. And that's kind of the gist of what the working data set is supposed to be about. And so once you set High, the in-memory automatic level High, as I said, we'll change the compression level to auto. Now, any pre-existing in-memory settings will not be changed. So that's good to remember, because if you've got certain things already set up, or you know that you want certain objects to always be in the column store, you can arrange that. So it wouldn't be Oracle if we didn't give you choices, and we do give you choices. And I did mention the priority thing. So in-memory priority is the way to ensure that an object cannot be evicted. And so this is something that I don't think is clear, and so I'll show you a little bit, but so if you set it in-memory priority to anything other than none, that object will get populated and will not be eligible to be evicted by AIM. So that's the way you get around not having objects evicted, even if maybe their usage isn't very high, but you want that object to be in the column store. And lastly, if you explicitly set an object to be no in memory, then AIM won't make it eligible to be populated. You can override the AIM behavior by explicitly saying, well, you know what, I never want this object to be in the column store. I just don't, for whatever reason. So with that, I have a bunch of slides that I did, but I'm going to skip over them and do that demo instead. So let's just show you how this works. So hopefully this comes out. I guess I didn't really resize this, but so what I have here is an environment that's running.
Sorry, Andy, before you get going, there was a quick question for you. And I thought it'd be appropriate because maybe you're going to show something about this. But the question is, with AIM, on a rack environment, if I'm doing it manually, I can specify duplicate or no duplicate for the object if I'm on an Exadata. So what happens with AIM in that scenario? Do I have that option?
Yes, yes. All of the existing, duplicate for service. You might have for service. So if you have AIM in memory automatic level, so in the demo here in my instance. So if you have in memory automatic level set, and now remember in rack you could set it to different values across different instances, or best practice would be to set it for all of the instances. But yeah, so it'll work and operate on each instance's access. So the access pattern for the column store objects will be based on each instance. So it'll act on the instance, but it's still going to act at the segment level. So depends on, so we have distribution. So we could have an object distributed across all of the rack nodes. So that's logically one column store. Or you might have a duplicate, which you mentioned, mirroring of IMCUs, but it's still a segment. You can have it duplicated across all column stores. So that would be IMCUs in each, but it's still logically one segment. Or you could populate it for service. So maybe you only populate the object in one or more column stores based on the service definition. And so AIM is going to operate on that object as a segment, a full segment. And so I haven't played with AIM much on rack. And so maybe that would be something we would do as a follow-on, is to show you some demonstrations of how that works in a rack environment with multiple instances, as opposed to this environment, which is just a single instance. So yeah, you still can use all of the existing features. And the idea is we will treat the column store as one logical column store, if you will. And that's kind of the scale of thing anyways. That's actually a good point. And so we should probably do some demos that way.
Yeah, we should actually. One more on that. Can I use AIM to experiment with the base level?
No, so you can't. Yeah, so that's we've documented that, and that's one of the restrictions with the base level feature is no AIM, only single compression, mem compressed per query low, no column exclusions, and there was one other, which if you want to know, you can simply go back to our AIM. We've done 2 AIM Ask Tom office hours sessions, so you can go back and look. But AIM is not available with the base level feature. Sorry about that. I lost Maria there, but I'm going to continue on for now. Hopefully she'll come back. So this is all controlled with the in-memory automatic level parameter. And so I've got here showing in-memory automatic level. It's by default, it's off. So I've set it to off just so that I can show you what things will look like. I actually have a couple windows here. I have my SSB schema, which I use for kind of all the demos we do. And so that's there. And I actually noticed I have my line order table enabled. It's in-memory priority of high. And so that's going to not be affected by AIM in the sense that it's probably already populated in the column store. And since I have an in-memory priority, AIM's not going to touch that. And so that object actually, we'll look in a second, but is going to be, on purpose, is going to be in the column store outside of AIM control. And then notice I have another one where I've actually literally set no in memory on the object. Notice it shows up under in-memory compression, so you can tell that I've explicitly made it no in memory. And so that means it's never going to be eligible, and we'll get back to this in a second. But and then I have in another schema, which is what we'll use for most of the demos, my AIM schema. or I've created a bunch of tables because we want to be able to put the column store under memory pressure. And this is just, these scripts, by the way, are just the scripts we use in our hands-on labs and the live lab environment. So there's no secret here. And then, of course, here's the query. It's just querying the attributes of the object from user tables. But notice I've got a bunch of tables. I was really, my naming convention isn't very sophisticated, but medium, large, and small tables, that's what that means. And it's all, they're just not enabled for memory. So just how you would if you just created the tables. So what happens now if we do an alter system and set our in-memory automatic level equal to high? So we've set the automatic in-memory level to high. Notice, before we just have our objects. Oops. Now look what's happened. We didn't do alter table, medium table 1 in memory, but we've now set, or AIM has now set that the compression level is set to auto, and that's the key to, and it's going to do this automatically. So basically, what's happening behind the covers is that all of the non-system objects are now enabled for in-memory. If we go back and look at our SSB schema, same thing. Actually, I could just do this. The same thing. So for the objects, now remember, line order and cust2 are kind of outside of AIM because I've purposely already set the in-memory, enabled line order for in-memory, and cust2 I said don't bother. But for the other objects that weren't set, auto. So all of these objects now are eligible to be populated in the column store. And so that's the automatic, or the automation that goes on under the covers. And what's as part of this part of the demo, I just want to, if we turn it back off, now let's cross our fingers. Takes just to go through and change everything. Boom, it's all undone again. So there is a way out of AIM if you don't want to use it for some reason, but it's all or nothing in the sense that you can't say, well, actually you can by altering the table, but basically AIM is going to be, it's going to go through and manage the entire database, if you will, or it's not going to manage it at all. And then of course still the low and medium options of AIM. So that's how literally how this works. And of course, this is uninteresting. So let's take a look at with it.
One question before you move on, Andy, if I may. Sorry.
Yeah. Oh, that's fine.
But it's to do with this. The question was, what exactly does Oracle use to control the temperature of the table? Is it just querying of those objects, i.e. that table appears in a query, or do we take into account DML as well to consider it for hotness, and also to consider it maybe not as a good candidate for the column store? That was the question.
I think the easiest answer is yes, but why don't we table that, because we're going to spend quite a bit of time on that, and I'll show it to you. We'll heat it up and see how that works. Kind of. The DML I wasn't planning on covering too much, but I'll show you that we do indeed track DML as well. So does you think that's fair?
Sounds awesome. Yeah, no, it's better to see it than to chat about it. Thanks.
All right, so let's turn this back on so that we have everything back to being managed automatically. So we're still there. And real quick, let's just, as I said, we check. So I have a script that, by the way, it just looks at $IM segments, but I don't want to type all that in. So it makes it easy to see. So we do indeed have our line order table. I will tell you that I found so 21C for on-premises isn't quite available yet. So I'm cheating a little, but I work for Oracle, so I get to, right? But this is the idea of giving you guys kind of a preview, because 21C is available in certain cloud flavors in the free tier, right? So so it's kind of there, but we have a bug that's actually been fixed, but it's not in the version I've got, where interval partition tables, which is what these audit tables are, these partitions are being included, but they won't be in the version you get. So just kind of ignore those for now. And when the product ships, that bug will be fixed. And so interval partition tables, which you can still have populated, but they're being included by default, and because in essence, these are system objects, not, and actually they shouldn't be included in AIM. But so that's just my caveat there. But bottom line is we have our line order table populated. And so let me flip back here before I start talking about the heat map or the access statistics, which that question was about, and which drives really the rest of our conversation. So I actually put these, what we just looked at, in there, but I'm going to skip over all that and go, let's talk about the usage statistics, which is, like I said, which is what drives AIM when we're under memory pressure. And so what's literally going to happen is, based on statistics, AIM takes over. And even when it's at the high level, even if you're not in memory pressure, AIM still takes over population. So I should qualify that, because AIM on low and medium levels operates under memory pressure. It does in the sense that it takes over population, but it won't evict or compress anything until there is memory pressure. So that's memory pressure, and then usage statistics are the two things that are driving how AIM works. So let me move on and talk about the fact that I'll do a little bit more about this, and we'll show it to you. But it's the access tracking, column statistics, other relative information about the objects is tracked, and it's in the underlying framework that drives both heat map and then the AIM version of heat map. But you don't have to enable heat map to make use of AIM. So you don't have to turn heat map on in order to use AIM. It's a separate, they are separate, for whatever that's worth. Anyways, so this is my picture about when we're talking about the stat windows, or the window that is used to track access. And so in 18C and 19C, this is where we're going to start getting confusing. So in 18C and 19C, the default was 31 days. The thinking kind of left over from automatic data optimization being that by default, you're going to look at a larger window of time of activity before we start evicting things. But now, since we're managing everything, we've changed that default to 1 day. So for just the current day is all we're going to look at those statistics, even though it's going to keep those statistics for a much longer period of time. I don't know if there's a limit, actually. So that'll be one thing I'll have to go back and look at. I don't remember. There is a way to clear the statistics, but what I don't know is, do we keep them forever, or are they on a rolling window? And I know we've had some questions about that, and I just don't remember how we wound up setting that. So I'll find that out and we'll document that. But bottom line is, this is important as we look at activity. And for our cases, we're just going to be 1 day. But again, remember I said you might have business processes that are weekly, daily, weekly, or interval-based, or monthly. And so you might actually want to have larger windows to make sure that objects that maybe don't get accessed all the time stay, or the exact opposite. You might get stuff that gets pounded on at one period of time, and you don't want a 31-day window, because then those objects would skew the population of the column store and never get accessed when other things should be accessed. So you get to control that. Again, it would be Oracle if you didn't get to make choices about things. And so we have two procedures. You can set the stat window dynamically whenever you want, and you can get what the current stat window is set to. And I actually did that here because I realized I really should, for completeness, have that in there. And so we have basically a call to get AIM get parameter, and our default is 1. So in 21C, the default is 1, and that's what we're going to be operating with in our demo. So that's the setup. So what AIM is going to do then, and there's a key part, I talked a little bit about the background process, the in-memory coordinator, and then on demand. These are the two things that will get AIM kicked off. And AIM is run through tasks. I'll talk a little bit about that. So it's always run in the background. It's actually outside the IMCO. All it does is kick it off, and tasks run in worker threads to manage all of this. So it's actually pretty efficient about keeping things in track. And I do want to, so it controls population. So we're going to add stuff. It controls eviction. But the other big change or thing I didn't fully appreciate is that it will also, if you're under memory pressure and you have objects that are still active, but not as hot as other objects, it can compress those objects rather than evicting them. So we'll try to compress things first. And we've done some sessions on compression and how it's not as bad as you might think, because it's not like zipping things. But all the compression that AIM does is at the column level. So I didn't appreciate that fully, because obviously when you enable an object frame memory, we have the mem compress option where you can say query low, query high, capacity low, capacity high. But we're actually in AIM doing this strictly at the column level, not at the segment level. So it's very possible that you'll have objects in the column store now that will be compressed with certain columns will be compressed and other columns that are more active won't be compressed. So we're keeping track of statistics at the column level in addition to the segment level. So just a takeaway there. There are a couple of views that we'll use. There's a tasks view, which is what I mentioned. All the work done by AIM is at the task level. And then you can look at, for each task, all of the sub or details of those tasks. And we'll do that in a minute. So I'm just kind of setting the table here of all the things we're going to talk about. And then I have a slide, but I'm going to skip over this because we're actually going to look at this. Oh, but the only thing, one of the reasons I made this was so that, remember back here, here, I said tasks can either be initiated by the IMCO, which typically runs every 2 minutes on a periodic basis, or they can be initiated by on-demand work that's going on. And so the only reason I had, or one of the big reasons I made this slide was, notice here that this is like banging away on tasks every 10 seconds, much faster than the IMCO is scheduled to run, which is what happens when there's not much going on. It runs every 2 minutes. So this basically shows, and I guess I should have labeled it, shows you the on-demand activity that's going to take place versus just the regular interval IMCO activities. So there's always going to be something going on, whether it's every 2 minutes or perhaps you have a bunch of activity going on in the column store, and AIM under the covers is going to be making sure that everything, doesn't mean that something's actually going to happen, but it's going to check to make sure that the most active segments are in the column store and you're getting the best value for the memory you've allocated. Hopefully that. You're going to be my check, Maria, to make sure that if I just go off the deep end and make this too complicated, that hopefully you can reel me back in. So, and then those tasks each have details associated with them, so you can kind of figure out what's happened during the running of AIM. So you can see that we evicted an object, we populated an object. Notice partial population. We'll talk about that a little bit. I will give a caveat that currently this is a little not as clear, in my opinion, as it could be. So I have an enhancement request going in to make this a little bit more user-friendly in the activities that AIM is doing. So this is kind of the growing pains of a new feature. But I thought it was a little bit harder to see, and we'll talk about that when we look at the actually running this. And but for now, task details will show you what AIM was either did or was doing during that particular task. And what else do I have in here? I have the heat map views. We're going to use this guy. And I've got another enhancement request to make this more user-friendly, but the histogram, and that's where we're going to take a look at the access statistics, and I'll show you that. And I will put, I I thought about this as I was writing up this Ask Tom lab. I have a feeling we're going to go over it. Hopefully not. We have enough time, I think. That I'm going to put some of these scripts that I've been using, and you'll see out on GitHub, so you can just go get them. You don't have to reinvent the wheel, because they are very useful. And I use a bunch of scripts in our hands-on labs, our live labs, and so I'm just going to make all of those ones that I actually use that I think are useful, and you can build on those on your own. So you don't have to worry about figuring out, oh my God, it's an underscore sysaim, and so I'll make that a little more user-friendly for you. And then I did mention, I'll just mention it really quickly, it is possible to clear it's called heat map. It clears the heat map, but the underlying information. So you could start over again if you're experimenting, if you want. But for the most part, there's no real reason to ever do that, but it's there. So I've documented this. Again, you'll have this because we're recording. And then we're going to, and this is the most interesting part, I think. That's the query, but I'll show it to you live, how you can figure out what's most active and what's probably going to get popular. And with that, yeah, okay. So now hopefully I haven't lost everybody at this point, but now we'll get back to kind of working through what's going on here. So are we good, Maria, you think? I don't know the questions.
We have one more, but I can save it for after the demo. Okay. So you go ahead.
All right, so let's go back and see. We know we're in level high, and we know we've got all of our objects that are set to auto, so they're going to be managed by AIM. Our current column store, since we've gone away, see if anything has occurred. No, we're still in the same spot we were because we haven't done anything. And that's one of the takeaways kind of have to remember. In an active system, there's going to be stuff going on all over the place. You know, here, this is my virtual box. I'm the only guy doing anything. And so it's very controlled. But in a real environment, you're going to have lots of concurrent processes and people running SQL and doing stuff. So looking at this like we're going to do now is not going to be quite the same thing, because you're not going to have that kind of control. So this is a good way to experiment, but in a live system, this is going to get complicated fast. So that's why we're depending on AIM to take care of this for us. So anyways, so that's what our current column store looks like. So I'm going to run what I call the heat map script, which I kind of showed you. That script is the same one that's in that slide, and I'm going to put this out on GitHub and make this available for folks. And we're going to make a more user-friendly version of this. But I added DBA objects so we could actually see what object we're operating on. So here's the heat map that I have currently in the system. Notice that I've ordered it by date. And so it's actually, that's what you do when you get demos. I'm not sure why it's showing up there as far as the 28th, because we haven't, did I do anything ahead of, I don't think I did anything ahead of time, but it doesn't really matter. The point is you can see based on timeframes what we're going to act on. And remember, since our stat window is 1 day, these are the guys we care about. So the rest of that, we actually don't really care about, because our stat window is only 1 day. Now, if we made our stat window 10 days, then it would take into account everything from today back 10 days worth. I think that's pretty obvious, but, or just as I just want to make sure I point that out, because everything that happens now is going to be effectively driven by the heat or the access statistics. So the answer to the question that got asked about does DML affect it, I'm only showing in number of full table scans. That's what that n_FTS. And hopefully this, yes. So we actually in heat map and then also in the underlying AIM access statistics, we do keep track of DML. So if you notice these columns, number of writes, number of inserts, number of updates. So we do actually keep track of that. And that's what that other statistics kind of caveat talks about. So we do keep track of DML as well. But for our purposes, we're just going to talk about the main driver, which is the number of full table scans. All right, so I have, now we're going to start to go off the reservation a little bit because I've I didn't really script this, so I want to make sure. Yeah, so let's see, based on our current heat map, let's see if we can get some of those large tables popped into the column store. Oops. So all this does is just runs a select count 10 times on the large table. So we're going to, basically all we're doing is we're going to artificially heat up some of our objects to see if we can get them aimed to say, oh yeah, we need to populate that in the column store. And let's do that one more time. I guess I could have, I think it makes more sense to run this individually rather than like, I could have just lit up a whole bunch of objects in a script, but, oh, and another caveat, which I will document in the script. The way the heat map statistics work, you have to reconnect to your session to see the updated stats. It's just the way it is. It basically, by reconnecting, it flushes the statistics in memory out to the data dictionary structures so that you can go look at them. And it's an efficiency thing, but if you don't remember that, you're going to be pounding on this and say, well, how come it doesn't ever change? And I speak from experience. So now we see that we have large table, here we go. And so 21 accesses. So I accessed it 21 times because I did 2 10s and I did probably a select on individually. So let's see if have we changed anything in the column store. And I don't want to take up too much time, but we did. So we heated it up enough for AIM to want to populate it. Now you could say, well, but it wasn't all the way full. The column store isn't all the way full, so it would have populated it anyways. And that's actually true. So let's see if we can do a couple others. And maybe I should have done, in hindsight, one that just did, we'll do large table 2. Maybe I should have done one where I just did a whole bunch to get under memory pressure in the first place. I had that last night and I kind of debated about how to do this, but I wanted to show the on and off stuff. So that kind of clears out all of what we've been doing. So let's, whoops. So bear with me just for a second as we heat up some of these tables, see if we can get things going. And I'll show you the tasks. Just show what's going on, and then do one more.
So Andy, while you're doing that, can I ask you one of the questions that came in? Because I think it's going to be a quick answer.
I'll try to type in.
The question is, are there any intentions to backport all of these enhancements to AIM to 19C, the long-term support release?
Yeah, you know, we've talked about it, but the changes for the high level are just too expensive to do that. And technically, you know, in Oracle speak, we're not supposed to backport huge new functionality into previous. So the answer is basically no. We have talked about it, but it just violates all the rules for doing that. And remember, the long-term release is we're supposed to build on the incremental releases, innovation releases, sorry, up to a long-term release, so that when you run a long-term release, you don't have to worry about us, adding a bunch of changes that could cause that long-term release to be unstable. Because the whole point is that should be a very stable release. So yeah, we've cheated and done things like giving you the base level feature, giving you blockchain support, but the high level of AIM is just too intrusive. And so I don't think that's probably ever going to happen. Now, never say never, but that's really kind of goes against the whole idea of the long-term release stability. So I don't think that's going to happen. Whoops, I didn't reconnect. Not that we have to look at this, but just to show that we're actually incrementing the access statistics that AIM is going to then evaluate. There we go. So, all right, let's see if we made any progress there. Ah, we did. Excellent. So with any luck, and actually there's not too much luck because I kind of planned it this way. This guy is the one that's currently going. So we've heated up these large table 1, 2, and 3. Actually, the medium table have statistics in them, probably because I ran earlier today and I just don't remember what I did. And so notice that the AIM is trying to populate the column store based on our statistics up here of the 28th. So these guys in here. So based on all that, it says, oh yeah, those are all hot. So those are the ones that should get populated. With any luck, we're not going to have enough room to get large table 2 fully populated. But while we're waiting for that, oh, there it is. So this brings up a couple of interesting questions, because when I first saw that, I said, oh, well, wait a minute. I thought we were only going to populate at the entire segment. So wouldn't you just populate the segment? If you can't get the segment all the way in column store, why are you going to populate it and have this situation where part of it's in the column store and part of it's not? And then our wise developers pointed out that, well, it's better to have part of the data populated than none of it. And so that's what happens. AIM will populate as much data as it can get based on the heap statistics or the access statistics. And if it doesn't fit, then we're truly under memory pressure. And now, based on our access statistics here, and as this changes based on activity, the population or the objects that are populated could change. And so what could happen is that, and I saw this in some of the experiments I was doing, is that as this time goes on, some of these large tables will wind up getting compressed. So AIM will say, well, wait a minute, you're not accessing certain tables as much, so we could actually, rather than evicting them, compress them and probably get enough memory to let this get fully populated, or maybe somebody else will jump in line and do it. So the point of all this is that this AIM is going to now manage this, and it's going to be based on activity. Does that make sense, Maria? Do you think we're okay still?
No, I think it makes perfect sense. I have a question that you'll probably hate me for, but as part of that decision to compress, is that one of the places where we may take into consideration the DML activities, those other activities, not just query that you showed?
So the generic answer is yes, but I will find out for sure, because to be honest, the algorithms to manage this activity, I don't fully have all the details of, and so I'm going to have to learn a little bit more about that. So that's a very good point. The answer is the answer is supposed to be yes, but I hesitate because I don't know and have not validated that. So that might be even AIM part 2, where we go through into a little more details about some of that. So I'm going to write this down. Fortunately, this is all recorded, so we have it for posterity. And I think that's an excellent follow-on, because I don't want to say that all of these things are in there. If they're not, they're supposed to be, but I haven't verified it. So
tune in next time, folks.
Tune in next time. There you go. Yeah. That's a teaser to get you to come back. Exactly. So while we're doing all this, and we've looked at the access patterns, and we know we're tracking statistics. I'm really only showing you the full table scans because I'm not doing any DML. But what's going on underneath the covers? How are we doing this? And so that goes back to that whole idea of tasks and running these subtasks to do the population, possibly compression, and possibly eviction. And so before we run out of time, here's what I'm only listing the last 2 days. So here's the tasks that we've been running. Notice it started kind of when I started populating the column store at 10:51, 53, 55. And so those are running on a kind of a 2-minute interval right now, and which is fine. It's just the way that works. So I wanted to show you task details. So for the last one, we can look at any one we want, but I'll just show you the last one. Now we can see that, and again, ignore these guys because they won't be there. That's just a problem with not being on the release that we're going to actually release, because I had to get an earlier version. But notice that it says line order is populate. So yeah, but that happened a long time ago. That didn't happen in this task. So that's one of the things I want to get cleared up, is to make this a little easier. So this is going to basically show us all of the objects that are enabled and active that AIM is currently tracking. So it's a little misleading in the sense this isn't going to show you necessarily exactly what happened during this task window. It's going to show you everything that it evaluated. Does that make sense? And so what I think is missing is, and what the enhancement request is about, is to make this a little clearer so you can see what actually occurred during that task, this 2605 task. And notice there's a whole bunch of things that it looked at and potentially did. But you get an idea of how it evaluated and says, well, line order is going to be populated, large table 2 is going to be populated, medium tab. So all these things are populated. Some of these didn't take any action on, and there could be eviction as well. So this is the way that you can go and see what AIM, how it evaluated the objects, and what action it thinks it either already took or needs to take. If that makes sense. And like I said, I fully agree that this is leaves a little to be desired as far as actually telling you exactly what occurred. And so we're going to fix that. At least I hope we'll fix it. I'm putting, so that's how that works in Oracle, is we'll put enhancement requests in for, just like if you file a bug for a problem, you can also, through my Oracle support, ask for an enhancement. And so that's what I'm going to basically do. And so there's a couple things that I've discovered. And so we have time before this actually gets out to everybody. And so hopefully we'll get that in place.
Awesome.
And hopefully I didn't say too much, but I don't think so. And so that's kind of everything that I think I wanted to cover.
Well, perfect timing, because we have hit the top of the hour.
Yeah, okay. Wow, I always say we should. I try to make these a little shorter so we can do lots of questions, but then we dive into the details here, and they wind up taking a little longer to go through. As always, before we close, if you have other questions about database and memory, we do have an AIM blog post that talks a little bit about the basics. Nothing this detailed, but it's coming. We're going to fully document all of this. I'm going to do a tech brief in addition, because I think this is absolutely huge. I think this is going to make database and memory so easy to use. It's going to take away a bunch of the questions that folks have about what objects do we populate. And so we're going to expand on this. And I think based on your guys' questions about DML and how do we track it, we'll probably have a follow-on as well, because I'm always looking for Ask Tom topics that are interesting. And so, as you can tell, I think this is pretty neat. So, and then don't forget that we also have our summit as well. So the InMemory Summit in June. I'm sure this topic, and we have just a boatload of 21C features that are coming out with database and memory. So this is just one of them. So I've done a couple of sessions already on new features, but there's lots of details about those. And so some of that we'll talk about in our summit.
Plus, and the link is in the chat. So if
it is in the chat. Okay,
it's
great.
in the
Thank
chat.
you very
Yeah.
much. I screwed that up and didn't give that to you, made you type it out. But summit, further questions, access to other information as well in our blog. Keep bookmark us so that when we put new posts out, you can see new information about database and memory. And boy, that was a full hour. It didn't seem like it, but hopefully that was useful. And again, thank you very much for attending. Thank you, Maria, for fielding questions and trying to keep me on track. And I guess that's
no worries.
Done.
Awesome. Thanks, folks. Thanks for joining us. Hope you found it useful. As Andy said, follow up on all of that useful information that he has available to you, and we'll see you next time.
Great. Thanks a lot.